Hello, my name is Rob. This is the first in a build series where we construct a hopped up version of this
Cyclops robot drone.
So let's have a look at the CAM files right away here. We're going to go over this section by section. We're starting off with a 3mm piece of stock carbon fiber. These outside holes are for arm mounts. They're 3mm diameter and they're countersunk from the top down. There's a few reasons for that. The main reason is the dome actually sits flush right over top of this. So that was the main reason why I did it. But honestly, it turned out so great looking, and there's a lot of strength benefits to using countersunk bolts. These inner holes are for the electronic stack mount. They're also 3mm bore, and they are actually countersunk from the bottom up. So that way there we leave the most amount of airflow for the DJI O3 air unit that's mounted between the top and bottom plate. These dome mount posts line up with dome mount posts that are mounted on a retaining ring that fits over the bottom, the base of the dome. So all you need is a 2mm rubber, similar to what we'd use for anti-vibration motor mounts. They're very easy to put on, very easy to take off, and you can have the dome on and off in like seconds. These slots here are for the motor wires to come in. There's no need to worry about feeding wires through holes, and which also makes taking the arms and motors off very easy and quick as well. Now, these two holes are for the power wires to come in from the battery. This slot is for the FPV antenna to come up from between the plates into the dome, and the same as this slot is for the FPV camera to come up into the dome. Now, this main circle is for a fan. There's the fan mount holes there, and because of the thickness of the part here, I just used a button head bolt from the bottom up. So the fan mounted here, the ESC sits right over top of the fan, so it's being kept very nice and cool. And the fan is blowing down onto a round heatsink that's thermally coupled to the top of the O3 air unit. And then so the last thing is everywhere except the arm mounts has all been brought down and milled down for a couple reasons. One, weight, and two, for increased airflow for the DJI air unit. Okay, so now let's go ahead and look at the sequence in the CAM file here. I always add comments because I don't have to worry about remembering what tools I used, where XY home is, and all that stuff. So we're starting off with a flat end mill. I used an extra long reach one for a reason that will become apparent here in a second. XY home is there. And here's a note: spoil board must be more than 11mm thick. So if you look at the inner holes are done first, and they're just done as a contour. It was an arbitrary decision whether I was going to use a drill bit or use an end mill. I just decided one less tool change, use the end mill. Now when it's done those, it does the outside, and you'll see that this is the reason why you need the spoil board thickness. See, these are milled right down into the spoil board 10mm in. So the reason for that is when I need to switch this part upside down so I can mill the bottom side of it, it's super simple. I don't have to re-zero any of the home or anything like that. Take the part off, remove the double-sided tape that I used to hold it down, flip it upside down and pin those holes into the spoil board. Okay, so the next step after that is to cut out the inner contours. And then the last step on this side is to cut out the outer contours. And there's a really important reason why we do the outer contour last. And that is because I'm using double-sided tape to hold this part down. If we were to cut this out first, then the only thing adhering the part down to the spoil board would just be the real estate of this part itself. By saving this till last, you have the whole entire stock holding down the carbon fiber. So the chances of it letting go in the middle of being milled is greatly reduced. So the next thing, we have a tool change here to a ball end mill. And we do that so that we can do the countersinking. I'll just zoom in here a little. Now, as you can see, I use a really small angle for doing this. It gives me a super great finish. I was really delighted with how it comes out by using this bore. Okay, and then after that we have a comment saying flip the part and pin the outside holes. And then we have a manual stop. So at this point the CNC would stop. For whatever reason it doesn't actually stop the VFD, but I just manually stop that. Move the y-axis so that I can get at the part. Take all the double-sided tape off, flip the part upside down, pin the outside holes, restore the position to where it was before, and then we go on with the next step, which is milling the countersinks on the bottom side for the electronic stack. Okay, and after that we have a switch back to the flat end mill. And then the last step is the adaptive clearing. And I cannot stress enough how important it is to use these simulations each time that you do any sort of step on this. You can zoom in as close as you want to. You can inspect to make sure that it's doing exactly what you want it to do. Sometimes there's a misinterpretation by the program. It may come outside of where you want it to mill into a part that you don't want disturbed. So, and this is just so interesting to watch how this operates. What a great piece of software. So the only other thing I can add about this is all of the metal used in this drone is non-magnetic, so the standoffs are all aluminum, the bolts are all stainless steel, and I think that's about everything that we need to talk about in this. So let's go ahead and make this top plate a reality. So the first thing we have to do here is fix this carbon fiber piece on here. So we want this corner to be used. Normally I would start back there and work my way this way, but seeing as that's not going to make a great shot, so we want this left corner stuck down. We get some double-sided tape. Try not to kink it if you can help it. So, and then we are going to put it right there. Pretty important to make sure you've pressed down really good on this. Just so you guys all know, it is cooking hot in this room today. I am sweating. Okay. So here is the top plate. And I actually had just finished going over the spoil board, so actually the machine has been homed, but I'll just do it again for the heck of it. Okay, so there we have the top plate. Let's start by doing a enable, and then home. Z was already basically home. X. And Y. Some of this stuff I'm not 100% sure on, like does this need to be all zeroed? I don't know. I just do it anyway because I think it should be. It may not even matter at all. So the next thing we are going to do is we are going to set our work X and Y. So again, when you look in the program, you'll see the notes, tool 1, spoil board, and XY home is bottom left. So we are going to set XY home now. Actually, we're going to put the tool in first, so let's bring this a little closer. Okay. Here is the long reach and mill. And I'm just going to verify that this will actually reach to the bottom without bottoming out. And yes, we have lots of room. Okay, Y continuous 60, X continuous 60. I just want it off the corner. You're only going to fit so many parts out of this anyway, so that's fine right there for work 0, for XY home, XY work home. So let's do that. We come into trace and set XY work home. Okay, now we can set the 0. So what we're going to do for setting the 0, find a decent spot on here. Where I don't see anything, and I'll use it. So Z step 1, and we'll just take her down 1 millimeter at a time till we're close, and we'll switch to 0.1 millimeter. And we're close, and we'll switch to 0.01. As soon as it starts to grab this paper, and you're there. And I'd say that's it right there. Go down 2 more just for good luck just to make sure I'm clearing everything. There's a command that I used to have to put in here manually, which was the tool and height offset. I have it programmed into here now, so I just press this. So now what you do is you come to offsets, turn this back to 0, do the gauge block here, check the tool table, it's all zeros, so that's good. Put this back to 1 and set the height here. And that's it, we are ready to start. So now what's going to happen, it will start, it will come up to the top, and now it's waiting for a tool change. And for whatever reason, it resets the height offset. So before you can start it again, I just come back in here and put it back to 1. We can start. And now I need the vacuum. Okay, that is it for the flat end mill on this side of the board. So now we're looking at a tool change to the ball end mill. Don't be dropping. which is a 6mm collet. So this collet will have to come out again. And for whatever reason, this collet is super tough to get in and out of here. I'll just leave it there for now. And grab the 6mm. Come on. Grab the ball end mill. That goes in so much nicer. Well, sometimes this thing's a bit of a bugger to get started. Okay. Tighten her down. Okay. Now, this needs to be moved over to the same area for doing a 0. So let's say x continuous 30%. And y continuous 30%. I think that's where I was. And z continuous 10%. Oops. Just make sure that you're... Sometimes some of the double-sided tape gets stuck inside of the flutes. And that's good enough. Step. 1mm steps. And that's close enough. Mach 4. Whenever you are at the bottom here, it assumes you've left it where it was at the top. So it will go immediately left right into the side of this work and snap the tool. So I found that out the hard way. So let's start by putting up the tool. At least that much. Okay, and then once you've done that, then you can go ahead and start. So you got the tool changed, you zeroed it, you changed it to tool 2 and to height offset 2. Now you may press the start button. Okay, that is it for the top side. And see what I mean? The VFD just keeps running. So we're gonna come over here. We're gonna tell this remember position. Shut the spindle off. Now we're gonna move the y-axis out of the way. So y continuous There. So now I'm going to pull the part off, take the double-sided tape off, and I'll be back with you when I've got that. There's no point sitting through that. Okay, so I've cleaned all the double-sided tape off, and now I am just pinning. It's very tight. It seriously does lock this part down exactly where it was sitting when it was on the other side. So now that that's all done, I turn the VFD, the spindle, back on. Make sure that you return to where you were. And then you're okay to start. Okay, so that is it for the ball end mill. We're gonna move this over X continuous plus to about where we were before when we did the change. Y continuous. About there. We'll take off the ball end mill. Thank you, ball end mill. And now we don't need the 6 anymore. Now we need the 1/8. Okay. And now back to the flat end mill. Oops, hey. Okay. Now we will zero the z-axis. And step 1 millimeter. Point 1 millimeter. 0.01 millimeter. And a couple extra for good luck. There. Now we're going to change back to tool 1. Very important, do not press start with the tool zeroed on the spoil board, or it will mean disaster. So come to Z, 10 US, and raise it up at least a little bit. And this will now we're safe to start. Okay, that is it for that. So, and there we have maybe Zoom will work a little better on this. So I just want to thank you guys for hanging out with me on this adventure. That is the top plate finished. So I think next time we'll do the bottom plate, and I hope to see you then. Take care. And don't forget, if you ever have a dream of flying, let's make your dream reality.